Yo, what's up everybody? Glad to be back. What's up Derek? And what's up Emena Pro? I'm good. I haven't been able to stream for at least a week. So we haven't really done that much when it comes to progress on the game. I haven't touched it in probably around a week, I think. So yeah, it's gonna be a slow start today. I did post a video with the water, and I must have changed something because when I booted it up and made it run today, I noticed that we still have this artifact right here, which I'm wondering about. So let's just see if we can get that back to normal again. Or is it... It's a bit annoying, but let's see. So yeah, haven't been doing any game dev for probably a week, so it's gonna take some time for me to get into this code again, but hopefully not too much. So let's see, try refract. We do multiple tries here, but I did change. It feels like it looks like we're only doing one try, which is okay. So first of all, I just want to get it back to where we were, and then we can see about improving it. The plan for today is to hopefully move on to... I just want to do a quick experiment with chromatic aberration on the outlines as well. But when we're done with that experiment and the fix of the edges here, we're gonna move to, I think it's the last underwater effect. Yeah, caustics, if that is how you pronounce it. But yeah, we're gonna move to this one and implement it, and I got sent a very nice tutorial on it, or something of that kind. Okay, but let's fix the edges first, or revert them to how they were. Maybe fix them. See if we can get chromatic aberration on the outlines, and then we move on to caustics, or however you pronounce it. Okay. Refraction success is equal to false. Then we do try refract, refraction multiplier. I'm not so... Yo, what's up Fabic? Good morning, good morning. Thank you for the donation. Appreciate it. Although I don't understand the message. What is epic fail? Fuck, I just have to say it feels good to be back. I missed it. Maximum refraction tries. Should be 3. Fabic, I don't... No, I didn't choose it. Okay. Well, I appreciate I appreciate it. Thank you, man. First of all, I just have to say that the solution I chose here, like doing this iteratively, I think eventually this is going to yield the best result, or depending on how many iterations you do, but maybe not for this case. Fuck, I wonder why didn't we have a very nice... What have I made? What have I changed for this to not work anymore? Very annoying. Water max refraction depth. Fabric, that slab style indeed. I fucking love it. I love it. Yo, what's up, Calvino? Good morning, good morning. Git diff, baby. Yeah, unfortunately... Unfortunately, I can't rely on that one right now. So this is how it went. Let me see if I can... If I can tell the history of this. Okay, so we did some changes. We got it to a correct state. I just wanted to fix one last thing before I commit it, because I want clean code in the repository. But then my son got sick and I haven't worked on this for almost a week, and now we're here. So like, I don't have, the master doesn't have the newer version, so I can't git diff, if that makes sense. Yo, what's up, Cooler SK? Yes, indeed, I'm back. Good morning, Geralt. Yeah, commit often, I would say. Yeah, rip indeed. This is like, okay, so this, I think we were about to fix the last thing and then commit it. Then I wanted to make that GIF of the water, had to do some small changes, and those are the small changes that's probably fucks this up. But yeah, that's how it goes. And I also have to say, this right here, this is something that is going to fix the edges, or help fix the edges, because we actually have terrain data here, so we know at what height the water is, and we know at what height the ground is, and using that information we can actually reduce the refraction at the edges. But I don't want to involve the terrain data just yet. Like, I want this water to work without being backed by terrain data first. But I think we can fix it pretty easily by doing this. We have something with, let's see here. I'm pretty sure what I've changed. And it has to do with scene water depth world space. Yeah, we don't use this one anymore in here, which sucks. We should... Have I? Okay. We want to use this one definitely. So let's see, normal world space. Scene water depth is scene depth and pixel depth. Beautiful. So we know how deep the water is here, and that's what we want to use here. So we want to use float, yeah, refraction. Yeah, this is the thing I've changed. Refraction wildness is equal to inverse lerp, and we want to go from, let's see here, what max refraction depth. In fact, here we have it, yeah. We want to take this one, and we want to do 0 max refraction, water max refraction depth, seen water depth in world space, and then we multiply refraction wildness here. And we do 0.5, 0.1, 2, 3. Yeah, we need to saturate it as well. There we go. There we have it. Okay, fucking great. What the max, I think, yeah. So that's about it. Beautiful. Yo, what's up, Jacoby? I have a question of how many times have you been heartbroken? What kind of question is that? Heartbroken. Actually, I don't think I've ever been heartbroken. Yo, what's up, Little Miss Murder? I hear you. Yeah, the outfit is clean as hell. Calvino, he's way too happy for someone standing in water with their white sneakers. That is definitely true. Unfortunately, we don't have any face expressions just yet. And Derek, amazing work. Appreciate it. I don't remember if I answered that. But okay, so now we have fixed the edges. That's beautiful. Now I just want to see if we can experiment with chromatic aberration on just the outlines. I just want to do some quick experimentation. We're not going to put too much time into that. And then we're going to move to cowsticks. And Little Miss Murder, do I remember correct? Was it you that sent me this source, which I'm going to rely on 100%, just so you know. Jacoby, just curious. Yeah, I'm going to have to think about that question and return. I'm not anticipating those kind of questions on Monday morning. Okay, so we should have chromatic aberration. I just need to check. Yeah, okay. I've done a change here. Refraction multiplier. Is it refraction tries to... No. 2 refraction tries. 2 to the power of 0 is 1, right? 2 to the power of 1 is 2. No, that's not what I want to do. We want to do... .5. So we get 1, 0.5, 0.25. I think we want to do it like this. Refraction exponent, that's not the correct name for it. Oh, I do. Okay, I get it. We do 0.5. Okay, now we're back. I'm gonna commit this right now also, so there we go. Let's just see if it works. Pretty good tutorial. Yeah, we're gonna look into it soon. See if we can get some nice caustics. Let's see if we have chromatic aberration working still. Yeah, we do. I'm wondering though. Red, blue. We don't have that much green. Why is that? Yo, what's up, Ray? I'm wondering, we don't get that much green here because I think green is... We don't offset green too much. I want to double check this. What's this? Looks cute. It's supposed to be a creature collecting game or creature attraction game, I guess is a better name for it, but we haven't gotten to the creatures just yet. We're doing some terraforming, or we have been doing terraforming for quite a while. And right now we're doing water. I recommend my YouTube if you want to know more. Okay, so this chromatic aberration strength, yeah, what we do here is we do RGB. So R gets offsetted by, or we use refraction index plus -1 times chromatic aberration strength. So for the green channel, this one is 0, so we don't do this one, we just do this. Although I wonder why, like if we offset R and B, we should be seeing more green, shouldn't we? I want to see what happens if we do I-1, 3. Yeah, definitely want to see more green. This is too much, however. chromatic, like water refraction index plus x multiplied by chromatic aberration strength. We never want that to, we can never allow for that to be more than 1, I don't think. .5, 0.5. Or I thought we would be getting some weird results if we make it war. I see lots of green, and maybe blue, red, and then we have some green here. But like, compare this to this. Here we can actually see, even though it's fractured a lot, Ray, damn someone that's actually writing HLSL instead of using shader graph. Mad respect. Appreciate it. Yeah, I moved back to HLSL from, so I started writing shaders using GLSL. So when I started developing in Unity, I started with HLSL, then they released shader graph. I started using that, but then I noticed that it didn't like have all the functionality I needed, so I reverted back to HLSL. I'm still on 21.2 though, so much of the functionality I would want in shader graph might be available these days. I really don't know. But for now, I'm sticking with HLSL. Maybe I'm just... Okay, here I think I can see more green here. I should really go with gray terrain, I think. I can definitely see more green here right now than if we do this, I think. Yeah, here I'm only seeing red and blue. Sometimes you can see a little bit of green. I'm just wondering if it's the... And Ray, thank you for the follow, by the way. So let's see here. This is... So chromatic aberration, all it comes down to pretty much is that we want to refract the different colors individually, right? So red, green, and blue. And the way we do it is that we assign a different refraction index per color channel, and then when we read the texture, we just read it 3 times with different refraction indices. And we're seeing like less green than I would assume we would see here, because the green one is really not offset that much, or that's the only reason I can think of. Kelvin, okay, my bad, I thought the blue was green, but I'm slightly colorblind. Actually, I was thinking the same. Like, it looks... It doesn't look straight blue, but yeah. I think it's more visible here. Blue, red. Here we have the green I would like to see. I wonder if we want to do... I wonder if we want to do this when we try this one. We jump to this one and we put this one at gray. And this one we actually want at... Can put this one at white and this one at white. So now we get a lot of red, we get a lot of blue, but not that much green. But if we offset all of them a lot, we get some fractured result, but here we see it a little bit better. What happens if we do I times 0.1 here instead? Or 0.25. But then I plus 0. Plus 1. This is how we do it. I plus 1 times chromatic aberration strength. That doesn't really yield the result I would like to see here. -1. So this camera angle doesn't show much green. This camera angle shows a lot of it. Because we're getting more refraction, yes. Let's add some more water here, first of all. This is what bothers me the most. Like, we're not getting any green from this angle, but maybe that's... No, that's probably not how we want it. So it's basically like this. Let me bring up this one and do some drawings. We have 3 values we want to refract. So we have the camera view getting down here to the water, and then we are refracting it. Let's not think about chromatic aberration right now and just do the without it. And then we refract it maybe like this, and then we use this direction to offset the texture read. But let's just say that we have the texture underneath here, and that's what we read from. So in this case we read from here, and that's the color we show here, basically. That's how we achieve this fake refraction. When we do chromatic aberration now, we have a chromatic aberration constant. Let's call it C is not the best one. Let's call it A. And when we try to read, when we read the red from the color texture, we do an offset in the negative direction, which is equal to A. And similar, when we read the blue channel, we do the same offset in this direction. But when we read the green channel, we do an offset 0, so our green channel, we don't get any offset from this one. And I'm wondering if that is what that doesn't show, or what makes the green color not show as much. Because, like, the closer we are to this point, basically, or no. Yeah, okay. When we do chromatic aberration, it's a fine line when we show the different colors. Like the less we offset from a big section of color like this, the more we're gonna read from. So when we read the texture, we're gonna get the same color for all 3 different channels, which means that the result is just white like this. I'm trying to make sense. I guess we could do... I wonder why we're getting such a bad result if we do I+1 instead. So I+1 basically means that instead of doing this, we do... So let's say that this is the point. We do... we offset this, the red color like this. We offset the blue color. Oh, actually green first. Yeah, and this seems like a very weird way to offset stuff. So I like this one because we're centered around the original point we were to read. Doing this, we just offset everything a big amount to the forward direction, I guess it is. But like if we uniformly want to if we uniformly want to place 3 values or 3 points around this point, unless we have a default offset, we're always going to get the middle one placed just at this point. But I don't know. So here it looks good. Here we can see green. Here we can see all the 3 different colors. But here we can't. One sec. Actually, Fuck, do I want to do... We could... I wonder if we would get a better result if we use the same refraction index for each channel, but when we have this direction here, we rotate this direction 3 times around view direction world space. Fuck, I want to try this real quick. So we're gonna do... let's comment this. And then we do, I think I have remap min angle axis. Yes, here we rotate angle around axis. I wonder if we can do... refraction direction world space, and then we do float 3 refraction direction world space. Oh, let's add rotate around axis. Oh, one sec. Yeah, we do. Okay, so let's do float 3x3 chromatic aberration matrix is equal to angle axis 120 around view direction world space, and then we do refraction direction world space. Fuck it, let's just create 3 different ones here. And instead of 120 here we do I times 120. 0, 120, 240, 360. I don't know if this will get a better result though, but... And then we do refraction direction world space is equal to this one times refraction direction world space. The other way around. I thought... Now it's gonna be this one. Float 3 times 3. What type mismatch are we talking about? View direction world space is a float 3. This one is a 3 times 3. We should be able to multiply like this. We have to do it like, sorry about that, mul matrix vector. I think this is way better. Fucking hell it is. Let me try and explain this. So this is way better. This is way better. Okay. Okay, I love what I'm seeing here. So what we did now, instead of doing offset like this, we calculate this refraction vector, and then for each chromatic aberration channel we actually just rotate it around this line, or the original view direction. So it's hard to explain in 2D. Let me see if I can open up Blender real quick. And this is way better actually. So what can I show this with? Curve, Bezier. Where do we have... Yeah, 0.5, 0.01. Can we get... We have 3D. Oh, is it actually... No, it's... Yes, it is. Okay, there we go. So... I don't need to show this plane, but let's see. So if we have the view angle coming down like this, okay, so with no refraction, we just look at what's ever located at this point here, but with refraction, what we do is that we rotate this one like this, this, or this. So let's say that our refraction and viewing angle gives us, or actually in this case, in this specific case, I think we're just refraction it like this maybe. Okay, so this is the refraction view and this is the original one. So if we don't have any refraction, we read this value. If we have refraction, we read this value. Previously we read it like this. So for R we read here, for G we read here, for blue we read here. What we do now instead is that we use the same refraction for all of them, so we get to around here, I guess. And then we actually rotate it around around this one. How can I do this in... let's do it like this. I think. Yeah. So instead of reading here, here, and here, what we do now is we read here, then we rotate it 120 degrees and read here, and then we rotate it 120 degrees and read here. So we pretty much read RGB values in a circle around the original point we would be reading from. I hope that makes sense, but it definitely gives the best result, that's for sure. Yo, what's up, Sama? Good morning, Robin. Are you self-taught or did you attend any specific course? Programming in general and graphics programming I learned at the university. Game dev is self-taught, but I guess like I had a pretty damn good foundation when I started doing games, so I wouldn't really call it self-taught, you know. But then again, is anyone really self-taught these days? I mean, okay, but this definitely gives such a way better result. So we're gonna rely on this solution instead for chromatic aberration. But I don't like the way we're doing it here right now, because basically what we're doing right now is in each iteration of this for loop, we're creating a matrix that rotates something, or the first matrix rotates something 120 degrees, the second one rotates it 240 degrees, or actually the first one rotates it 0 degrees, the second one 120 degrees, and the third one 240 degrees. What we could do instead is we just create one matrix that rotates something 120 degrees, and then we reuse that matrix, because this one is, yeah, it's a rotation matrix. Whatever vector we multiply with this matrix gets rotated 120 degrees around this vector, right? So definitely don't want to recreate this one every time. So eventually I want to move this one up here. Chromatic aberration matrix. We're going to refract like this, and we can see now, so water refraction index, this one is the same every time. It's actually only this one, so we don't need this anymore. But then we need to rotate this one, and we're gonna do it like this. We're gonna take this one and we're gonna put it up here, or this is where we're gonna define it. Let's put it here. So we calculate refraction direction world space, chromatic aberration matrix, and then for each iteration here, we do refraction direction world space is equal to itself multiplied by chromatic aberration matrix. So it should be, we can do 120 here. I wonder if I want to add this as a property as well. We're going to look into that if it makes any difference. But yeah, this should yield roughly the same result, yes. Sama, in terms of programming your own shaders, do you recommend any online courses, tutorials, so I could understand the fundamentals, all the geometry of the calculator? First of all, are we talking like shaders, making shaders in general, or are we talking making shaders in Unity? I want to know how general I should be in Unity. I don't think I know. It definitely exists, but I don't know about any site that brings you from like a novice to a pro that goes through everything. I have some pretty good resources I use though, which I could link you. So please write to me on Discord or just send me an email. My email should be available on YouTube. And after the stream I could send you some resources that I like to use from some great people. Fabic, with all the AI we're at a point that there will be no more learning, just ask the AI. Maybe. But wow, this chromatic aberration solution is so much better. With this one we never get the issue of going above a water refraction index of 1 either. So this is great, I would say. This is fucking amazing actually. Ooh, this one right here though. I wonder about this one. Calvino, that looks dope. Nice improvement. Yes, indeed. I think this is very good. Very nice improvement. Sema, much obliged. I will write to you later on. I appreciate it very much, Robin. Thank you. Appreciate it. Appreciate you. And you too, you too. Okay, so yeah, this is very nice. So at places where we have lot of refraction, we get... this looks very nice. Like, this solution also yields us... We could have... We basically don't have any refraction here, and then we get a big wave, and the quote-unquote light gets refracted a lot, and we get effects like this. That's very nice. Although this still bothers me. This is not a refraction problem per se. But we're pretty much at refraction. We should not refract any at all right now, but we're still seeing some small refractions. Definitely need to write that up as an error for now. Let's close this one. Some areas. Yes, something like that. Just so I don't forget it. I'm talking about these. I wonder if there's some... I wonder if we have... I'm just guessing right now, but it could be at some points we should be getting a 0 or 1 value, but we're getting something less than 0 or bigger than 1, so it's a saturate or clamp issue, but I don't know. And then I want to try one thing here. So chromatic aberration strength, we can't really control this one right now. Or we don't have anything specifically for chromatic aberration. Chromatic aberration is now tied to water refraction. So the more we refract, the more chromatic aberration we get. Which I don't... Refraction strength. We could do 120. Ooh, let me try. Let's do this. We do chromatic aberration, chromatic strength. Let's put this one at a range 0 and 120 instead. And then we use this one in... We put this one here. Chromatic aberration strength. Whoa, 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 whoa. Are we... I don't think we should be working with... angle axis. Fuck, are we working with radians here? Rotation. Fuck yeah, we are. Or are we? Yeah, we are. Let's not make that issue again. So let's do let's bring this one back to a range of 0 and 1, and then we do And then we do chromatic aberration strength times pi. 180, let's do 2 times pi. So 0 and 1 here should result in the same. Let's see. So 1, and then we do this. Okay, so now we can have small chromatic aberration. We can go, but yeah, so it's just up to 120, I think, that we get. It's just up to 120. Then we're just rotating everything. And I don't know. But is that something I want to? Red, green, blue. Red, green, blue. Yeah, we probably want this one to be, okay, between 0 and 1, but 1 should just be 120. So what is that? 2 pi divided by 3, right? We can do 2, 3. Okay. 2.0, 3.0. There we go. So this is maximum chromatic aberration. It's pretty wild. Probably never gonna use this one, but we can go. So we can just do so very, very small, barely visible. Okay, that's very nice. Let's just restart everything so we don't have the weird colors. Okay, let's see. This is another thing I want to see. So you can see this artifact we have here. This one is used to decrease the original artifact we get from how do I see? That we get from refraction. But if we don't have any refraction, we don't need to rely on it, right? So that I don't want. That I want to fix as well. Uh, 0.05, 0.15. Okay, so if we do chromatic aberration right now, it looks a little like this. Okay, that's pretty good. Do we still have the same issue? No, I think we're fine. Yeah, now it's the blue one we don't see that well because the water is bluish. But okay, yeah, this is much better. Okay, great. Yeah, so let's move on to caustics. Let's double check how to actually pronounce that one. Caustics, okay. So let's disable this one. We're probably gonna disable the refraction as well, but we still have this issue, and we have this issue. So let's see, refraction leftovers. Let's do refraction leftovers 2. And what do we call it? We call it water refraction edge remap. Water refraction edge remap is still active, is still done while refraction is at -1. Okay. Ooh, let me commit this one as well. Do I have some leftover stuff here which I don't want to commit yet? This, So let's uncomment that. And that. I think we're gonna get an error now as well. Or maybe not. Okay, so chromatic aberration, we add this flag here. So if we have chromatic aberration, we use these methods instead. If we don't, we use these. Oh, one sec, I forgot. I want to double check chromatic aberration on the outlines as well before we move to caustics. But let's commit this real quick first. Yeah. And before we commit it, I think I'm gonna delete this one as well. So let's see here. Add chromatic aberration. related to 35. Okay, there we go. Okay, so let's see if I can make this visible, or if it's actually that visible. So if we take a look at the refraction here and we add chromatic aberration, and we do it a lot, yes, we can see here that the outlines, they are not taken into account. The outlines are black, however, so I wonder how this will look. But I want to experiment with it a little bit at least. So it's scene UV, outline UV. Let's see. Try refract. We do outline UV is just what it is. Okay, this might get messy. And the reason we split these are because get scene information. Yo, what's up, cool? Outline data. Yeah, I think this should be easier. I think, fuck, I wonder how this will work with a black color actually. Let's see what we can do. How are you? I'm fine, cool. Thank you for asking. How about you? And God, I hate HLSL. Why? I love it. So I'm thinking about restructuring scene information here. So we're not going to have outline data here anymore. I don't think. How do you actually do chromatic aberration on a black color? Like if we work with colors in the RGB space, so black color is just 0, 0, 0. So are we gonna get chromatic aberration that is we have to define ourselves here how we want to handle it. I would have thought that, or I want to handle it like, I want to handle the outline like if it were white. So if we do chromatic aberration on it, I would like the black outline to split up into red, green, blue. Let's try that and see how it looks. So yeah, the first thing we're gonna do is we're gonna do scene color, UV refracted. Yeah, we just refract the UVs here, and then when we do color here, we do scene color, yes. Get scene information split. Fuck. Are we gonna have to do all of this? How would I like to go forward here? It's probably around here. Outline is just a float. We want to change this to color. And yes, then we add like this. Okay, let's alter it in the non-chromatic aberration first. So I think I want to switch this up to outline data. I wonder, do we need it? Okay, we don't need this one here actually. We're gonna do this. Float 4. Let's change it. Let's do this. Let's make this work first of all. Again. So we do Scene information. We switch this one to outline color. Outline depth, outline color. We read the data here, outline data, and then we do so then we don't need to reconstruct outline color either, I don't think. Reconstructed outline color is equal to outline color RGB, outline color, yes. So let's take this one. And put it here. Like this, and then we do, okay, we don't have outline data, so we do float for outline data, and then we do s.outline color is equal to this one, outline color RGB, and here we do outline data dot r. So R is the alpha of the outline, G is the depth, which we can see here. And so here we just do this. So then we have fixed it here. And here we do S outline color. Yeah, S outline color is equal to S refracted outline color. Okay, and then I want to check outline data. We use it here. Let's see, here, 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 here. We no longer use it outside here. Okay, so outline float for outline. S is equal to outline color. And then we have this one here. So outline total weight times S offset outline color. Outline, and then we do outline divided by outline count. Fuck, do we still want to do? Yeah, I think we want to do it here. And then we have something called reconstructed outline color here. So we just remove this one and do outline here instead. That should be it. Okay. 591. Oh, outline is equal to 0. Yeah, outline dot A, if that one is equal to 0. Hmm. Hmm. I think this looks pretty much exactly the same. That's good. Okay. So let's see. What I want to do now is we want to get this change into chromatic aberration as well, so we can split up the outline. So let's jump to chromatic aberration. Outline data, we don't do this one anymore, we do outline color. And I wonder if we might not need to split up outline UV and scene UV anymore. Actually, one sec. Scene UV. Oh yeah, we do need to have these as separate because when we blur based on depth, for instance, you might have the scene color might be located way back, but then you have an outline in front of that one that hasn't the same depth. Okay, so we need to have these split. But let's see here. I think we want to make this into 4 eventually as well. We might just do it now. And then we have outline color here, and why should be able to just do this. And yes, then we want to read the outline data. I want to reconstruct the outline here as well. So outline color, that is. Okay, something like this for this one, and then this one is going to be a mess. So much like we do here and here. Do I want to put... Yeah, maybe it's cleaner to do some reordering here. So we do put scene depth there. So we keep scene and outline like this. And then we put this one here. Yeah, this is much cleaner. Let's do the same here. No. There we go, right. Scene color, scene depth, outline color, outline depth. Yeah, this one is still down there. We're gonna change this one soon. Fuck, doing the outline data is gonna be rough. So chromatic aberration is extremely costly. It's extremely costly by default, I would say, because when it comes to color and depth, we're talking about, so essentially just color and depth is like 8 texture reads. But we double that amount if we add outlines as well. Fuck me. Yeah, we want to do a min here as well. I think how we want to do this is... Okay, let's do something like this. Float 4 outline data is equal to new outline data 4 is equal to oops. For texture reads. One sec. Oh, yeah, this is pretty stupid. So instead of doing this, or we might just do this once, sample scene depth. Like instead of doing this 4 times here, we just do it once here and we do min first. Or here, I mean. Might need to change it to, and I can't seem to remember oops. If like we get, if depth is reverted by default and then this one changes it back, but let's try this. Sample scene depth. I wonder if we want to do okay. So when we do the color here now, we want to do s.outline color is equal to float 4, and basically want to reconstruct it 3 times, I suppose. So let's see here, float 4, but not really though. Outline color RGB. I wonder if we want to do it like this. Let's see. Outline color R times outline data 0 dot R outline color dot G times outline data 1 dot R. And then we have the alpha. This one is going to be a little bit different. This one is going to be min. Bit between this one, and this one, I think. I wonder what weird result we will get from this. But let's try it. And outline depth, we're gonna need to do something similar here. So here we're gonna do min between essentially this, but G. Okay, we need to do this as well for outlines. Scene UV. Okay, so that's about it for that, I think. So now it's the refraction. So this one is the, however we handle it here is the most important. So this is gonna, I think, maybe this was the most important part, but let's see here. What do we need to do here? UV refracted. Okay, we need to refract. How do we do it? UV refracted. S refracted. Oh yeah, we refract it like this. Get scene information, UV refracted, UV refracted. Okay. Get scene information split. Here we just do UV refracted one. Ooh. Okay. I'm wondering if what we need to do here might just be as easy as doing this. But We might get some issues given thanks to this one actually. But I wonder how. Might need to have I wonder if this is the only thing. Yeah, maybe. And that means that we need to have... Yeah, we need to separate all of these per... Okay, that's gonna be a little bit weird. But maybe, let's see what kind of result we get with this first of all. Let's see if we have any errors. Yes. Unexpected token S, 343. I need to go through all of these later on as well. 397 outline data. Oh, yes. Outline color. Outline color. It pretty much looks like we don't have any outline right now. Yeah, we lose the outlines as soon as we start chromatic aberration. And also we don't get the colorization we want here as well. Or do we? No, we don't. We do still get it without chromatic aberration, right? Or do we? No, we don't. And that is because of reconstructed outline. It could very well be because of, let's see here. It could be because of, no, it shouldn't be. I was thinking about this one, but no, it's not. We can reconstruct it the same way here. Total weight. I don't see how this could possibly screw it up like that. Outline data G. Yeah, it's definitely, let's see here. If outline is equal to then we blend outline to color. And then we do, if outline depth is bigger than pixel depth and seed outline depth similar, it's this one that fails. But why does it fail? Because outline depth. That's the only reason I can see, unless we do outline divided by outline count, total weight, outline color. Outline color RGB, outline color A times outline data R. It has to be this one, I think. But I don't see it. Unless S dot outline color. Oh. Fuck. It shouldn't be this one either. It shouldn't be that we multiply the outline color alpha with outline data R here this early, because this one is 1. So that shouldn't affect it. And it's also extremely weird that it works here, but it doesn't work here. Refraction. Okay, even without refraction, it still fails. And then we have this issue as well. Fuck is going on here? It succeeds here, but not here. What's the logic behind this? Scene and outline depth similar. Scene depth, outline depth. Okay. That is the problem we have. Yo, what's up, Spies? Good morning, good morning. Thank you, appreciate it, and thank you for the raid. Enjoy your lunch. And welcome to all the new viewers. Over here we are fighting with refraction, but not only refraction, we're trying to include chromatic aberration as well. But what makes it a little bit more difficult is that we want to do it on the outlines as well. And that's what we're doing right now. Yeah, and the problem we have with chromatic aberration right now with the outlines is that the outlines, they pretty much just disappear at this point. So the chromatic aberration with those, it's not being calculated correctly, I think. Or you don't say. And I'm pretty sure it has to do with, or actually, like doing chromatic aberration on, like doing it on a black color is it's like a special case, I think. So my question is, do we need to handle it like, do we need to handle it like it's a white color? That's what I'm worried about. Never mind. Here we want to do max, actually. We want to get the max outline. Right. Let's see what we have now with chromatic aberration. Yeah, fuck, this is not what I... And this is one this is one way to do it, I guess. Fuck, is this how I want to do it? Nah. Plus we actually get this artifact here as well. That's rough. And I know why. But actually, is this... I don't think... this is what we want. Yeah, we just get multiple outlines. That's... Actually, one sec. We have a problem as well. Yeah, it's not... What the hell is going on here? I want to compare... definitely want to avoid this. I wonder if... definitely this as well. I wonder... did we have this issue? Before I started messing with outlines, we didn't have this issue, right? I don't think so. Yeah, and the issue we're seeing here, I wonder if that has to do with this one. Sample scene depth. I wonder if we want to do max. Okay, that's better. So how do I want to handle the outlines? I wonder if we want to do what did we put here previously? We had UV refracted 1. Float 2. We just used a simple outline here. Which one was it? Yeah, it was UV refracted 1. I'm wondering. I don't know how I want to handle this. I'm wondering if probably want to refract the outlines on their own rules. We pretty much don't want them to refract as much. Ooh. This one. Still not, and if S outline depth is bigger than depth threshold, outline depth min, oh yeah. Okay, now we don't have that issue. Is this how I want to handle it? I don't think so. It's way too busy. Way too busy. And also we want to do, let's see here. When we do chromatic aberration here, we want to start at maybe. When we do the chromatic aberration right now, it's basically like this. So we have the view, and then we have some refraction up to here, and then we basically have a refraction sphere around this view. And when we refract, we do so R, we rotate it once with chromatic strength times at most 120. So it can look like this. We take this point and we refract it once here, here, and here. But if we increase the refraction strength to max, we get here, here. Oops, that should be green. Here and here. So this is a nice distribution. This is not such a nice distribution. I would like to offset this one. So I would always like it to be centered around the original one. So this one I would like to bring to here. But that means that we need to do angle axis twice. We need to get 2 matrices. I wonder... If we do the outlines as well, right now it looks like we split the color channels and then we split the outlines, and the outlines are black. Do we want to make them more green here? That's probably how we want to handle it. So at this point we don't get black, black, black outline, we get RGB outline. Not entirely sure what's going on here either. That's not good. Joseph and a Technicolor Adidas sweatpants. It looks pretty damn good. Little Murray, you should write a book when you're done. What kind of book are we talking about here? Unity from scratch. I don't know if I'm the correct person to do that. Okay, so when we reconstruct the outline color here, outline color R times outline color R. Why? outline, S outline color. Why is the outlines? I wonder if I want to do this. How weird would it look if we did where do we have it? Here. How weird would it look if we did this? 1 minus yeah, it's getting white here, but now we get looks a little bit better, but not much. The problem with book writers is they are subject matters experts usually and forget what it's like not knowing your R's from your elbow. I'm sure you have a million tips and pitfalls you've discovered that you would not find in any Unity course material. That might be true. Yo, what's up, Smack GDs? How goes the game dev? It goes. Okay, I'm pretty sure this is not what we want to do. Fuck me. But although I do like this more, I think, and so it means that it's a problem with doing chromatic aberration on black, because the way we do it, we pretty much get black. Which means that we get 3 different black outlines. Smack GDs, by the way, how goes the game dev for you? Yo, what's up, Diligence? Good day. Where you've been the last week? My son was sick, so I had to take care of him. Or he wasn't that sick, but I wasn't able to stream. Probably what we want to achieve here is, if the outline is purely by itself, we want it to be red, but when they overlap, we want them to add to each other. Maybe. Maybe we want to take this into account. I keep going on vacations and can't finish what I started. Sounds like life indeed. Or D-life. Fuck, I'm pretty sure the original solution was better, right? Yeah, I'm a little bit worried about the triple outline here. It's noisy. Noisy, noisy, noisy. It's too much black, I agree. Emo chromatic aberration is firmly in less is more territory. Yeah, we're probably not gonna run with chromatic aberration, if any, on the water, honestly. But then again, like, I want to make this water shader pretty general. And I want to support oily fluids eventually. Fuck, this is a problem, like. And what is with this one? Let's do. So 1, 2, 3. I can't really decide. Do I think this looks good or not? Where do we have... settings... Oh yeah, of course. Try with depth blur. Yeah, with some depth blur it looks better, definitely. I'm still not sure exactly what's going on here, though. Trippy indeed, indeed. This one boggles my mind. So it seems like we're getting... This one doesn't have any color tied to it, does it? Or is it blue? Ah, because we have blue pants, maybe. I'm thinking without including the outline is probably best. Or is it? It looks weird though when we have a lot of chromatic aberration like this. Or we could do... This is probably best, I guess. Right, just keeping one outline and letting the color bleed. Doesn't get too messy. This compared to... Derek, I personally like it with the outlines, so we're talking when we do... So like this. Fuck, I can't decide. I'm gonna have to... And we need to fix this as well. Yeah. This... It feels like we're getting one... Are we getting one outline too many? Like, there's pretty much no color tied to this outline. Unless... Or is this blue, but we don't get blue here because of the color of the pants? Is that it? Does that make sense? Yeah, it's the blue color channel that don't have any color. attached to it. What the the fuck? Okay, but anyway, first of all, I need to fix this issue. We need to evenly distribute the chromatic aberration around this point instead of offsetting like this. You can pretty much see the circular motion the more chromatic aberration we add. So I wonder, do we need one extra? Yeah, probably. So util math. Something like that. So we need to do refraction, direction, world space. We do refraction, direction, world space is equal to rotate around axis. Do we want to do minus this one? Times pi view direction world space, and then we calculate this. We still want this one here, I think. Then we calculate this one, and then we move this one down to here. So first of all, we rotate this one backwards one step. Then we use that one, then we add, and we add. I think this should be better. Or I thought 377. Yeah, we need to have. Oh, it's not view direction here, it's refraction direction world space. I think this should be better. Is it? It's not entirely correct. Why not? Or is it? So instead of going this, yeah, so instead of going this, we move it back one, and then we go this. Like we bring all of this back here. It should be like that. So we start by rotating it back. Chromatic aberration strength times, yeah, this. What am I missing? Definitely feels like we're going to RGB. Yeah, we're moving. Pi divided by 3. Yes. No, it should. Okay, that explains it. There we go. Now we have a better. Much better. Right. Okay, so now back to the question. Outlines or not? Like if we would be doing white outlines, I think it would look way better if, like if we would have had white outlines, I think we definitely want to split them. But like it's a special case with black outlines and chromatic aberration. Like if we would have had white outlines everywhere, actually we can try it like this instead. Let's do it like this, and can I alter it? Or what's happening? Or like, okay, the question is, what could we do to make this less noisy? We could do this as well. Oof. Fuck, how would that look? What if we did... Maybe, one sec. Maybe we could go with one outline and we try to position it in the middle of everything. So like if we do like the average position, if we do UV test here, we just go with one UV refracted 1, which means that we're going to be placed at the original one, so it's going to be green channel. I wonder if it would look better if we would place the outlines in the middle of all of these three, but I don't know about that. So the outlines would be located here. I don't know. This looks way better. Let's try. Okay, the last experiment I'm going to do with chromatic aberration. I think I'm going to keep it like this. Okay, if the last experiment doesn't work out, we're going to keep it like this. I think that's the best option. It's not as noisy, but it looks a little bit weird here, so it's tied to green. We could put it in the middle as well. But before I continue, just give me 1 minute. So back, sorry about that. So if we want to put it in the middle, we're gonna have to do interpolate between UV 0 and 1, and then interpolate between... we can do barycentric coordinate. Probably. It's pretty much a triangle we use. Yes, I think we could. We have util math here. interpolate pericentric P1, P2, P3, and then T. So we do. Let's see, UV. Let's do float 2. UV test 2 or single is equal to interpolate barycentric UV refracted 0, UV refracted 1, 2, and then we do float 3 divided by 3. So UV test single. Is this what I want? Oh, so if we have max, we don't even refract the outlines. Because yeah, then we're in the middle point. That's not good. And let's just do what am I missing? UV test. Oh yeah. So either we keep the outlines to one of the other channels, in this case the green channel, or we interpolate the UV for the outlines between all of them, which doesn't work when we're at max. Actually, does it work? This is probably the best, right? Diligence humidity, the outlines become pixelated underwater. I think. I don't know how much anti-aliasing we... I'm pretty sure this is the best option. The only problem being then if we max this one out, we just have outlines like this. Or the more we max it out, the less it refracts. Oh, that is definitely a problem. Oof. There we have no chromatic aberration. I don't think the pixelation is that visible at full screen, however. Something like this is probably the best solution, but then we can't max chromatic aberration. Let me add all three real quick and we're gonna compare, see which one is best. Or actually, whoa. Diligence, I think the chromatic should be more subtle. It looks so clean without. Yeah, we're not gonna have, like, right now I'm in the process of developing this water shader, and like we want to make it as general as possible. So for some fluids we would like max chromatic aberration. For some fluids, for water or for clean water, we're not gonna have any chromatic aberration. But like right now I'm in the phase where I want to make sure that no chromatic aberration looks good and full chromatic aberration looks good. So yeah, for water this is definitely better, right? But for oil we would probably want this. But I do agree with you, like, I love the look of this. Like, this is so nice. Yeah, but this one is unfortunate. So at max chromatic aberration, it no longer works. Or since we're interpolating the outlines. What can I do about this case? Okay, so Diligence, we have three different ways of handling the outlines right now. Either we handle them each per channel, that's when we get a lot of outlines and it looks a little bit messy. Or we could make the outlines follow one of the channels, for instance the green, the red or the blue. Or what we're doing now is that we interpolate the outlines so they are always located in the middle of all three. The problem with that is if we do maximum chromatic aberration, this means that we have the three chromatic aberration points are located uniformly on a sphere around the view direction or viewpoint, which means that when we distort these outlines we don't get any refraction because they are aligned with the view vector. If we just have a little bit of chromatic aberration, it looks good. But then again, I think, like, for small chromatic aberration, this is probably the way to go, having the outline be in the middle of the different colored channels. Yeah, I'm pretty sure. Just gonna, but I don't know how to handle this case. One sec, we could do... We could also do, I wonder how this, we can try a lot of different things here. So right now we do the middle point here. We could do we could make it interpolate towards the strongest color we have. Maybe that's... let's see how that looks. How would we go about doing that? Derek, no outlines in real world physically based is of fun. Yeah, exactly. Is it because all three colors average is the same as default position? Yes. So it's this one. So real quick, we have a viewpoint, so this is where our view ends up. Then we refract it, so we get here pretty much. Then we do chromatic aberration, and we uniformly place 3 points around the viewpoint. If we have low chromatic aberration, we place 3 points like this, basically. If we have max chromatic aberration, we place 3 points like this, so 120 degrees around the circle. And if we do barycentric coordinates of the triangle formed by those, we're going to get the middle of the triangle, which is our viewpoint, which means that when we fetch from the color texture, we just get whatever color we should have if we had no refraction at all. Yeah. But what we could try is we can do float sum is equal we can't do it here. Let's see, we can do it UV test, UV refracted, get scene information split. Let's do this, UV refracted, and then we do get scene information split. When we get the outline data here, we do this UV outline test. And then we do float sum is equal to s.sceneColor.r plus s.sceneColor.g s.sceneColor.b. And then when we do the barycentric coordinates here, we do s.sceneColor.r divided by sum, and then we do RGB. So what I'm trying to get at here is that when we do barycentric coordinates here, we place the point more towards, like, the stronger the color is for these points, the more towards those we place it. So if this is the one that has the highest color value, we place, and these two are equal, we will place the UV here basically. I just want to see what kind of result we get from this. So are we doing it correct? We sum the colors, the color values for each channel. And then we do outline test here. Undeclared value 338. Oh yeah, here we don't use UV refracted, we want to use UV seen. Whoa, is this actually what we get? That's a weird result, but and how does it look? It's extremely weird. Diligence, humility, add each time you will never end up in the same spot in the circle. Yeah, we could try something like that, adding a random number based on something. Definitely. Like, I wonder if this one... Right. Okay, we don't want to do this. But if we keep this one here and do... Yeah, I mean, we could just do... we could just do... Yeah, this is the best one so far, I would say, but only for low values here. So we could add some random number to get it. So the bigger we have... we want to displace this one at higher values, but it feels like we need to add some logic to how we displace it. If we displace it with a random number-ish, it's gonna look extremely noisy, I think. Yeah, pretty sure. But... if we rotate this one around as well, what I hate, if we have a distribution like this, we actually get a very good value. If the triangle becomes big, we get a very bad value. We could choose to always place it... I would like to avoid... phi is the constant like pi. Nature uses it to distribute on a circle to never hit the same spot twice. Yeah, the problem is if we uniformly... like, we want to uniformly place these 3 points on the circle. Like, we always want this channel to distort as much as this channel. The problem is... the problem is when we get them... when we have the same space between each point. But if we use... did it look bad when you only made outline for one color? Yeah, I don't like... so then you can really see that the outline is tied to one specific channel, and I want to avoid that as well. Like, I'm probably gonna make... I'm gonna record all 3 different variation and just post it. Have some sort of... like, let people say which one they like the best, and probably go with that one. And that means tying the outline to one color, doing the average, and having outlines per color channel as well. But if I want to have... so this solution we're working with now, like for low distortion, this one is the best, I would say. I like that it's located in the middle of all the 3 different options. The only problem with it is this, right? But actually, what the fuck? Oh. Oh, yes. Okay. So right now what we do is we have a viewpoint, then we refract it, then we place the chromatic aberration points based on that refraction, rotate it around the viewpoint. What we want to do is we have the viewpoint, then we distort it, then we get this point, then we distort it again, and we place, yeah, what the fuck, and then we place them here, and we always place them. Oh, yes, that's what we want to do, and then we use the outline for this one. What the hell? That's the straightforward answer. That's fucking great. So that means that we distort it twice, though, per color channel. Oh, yes. Now we're talking. So we want to do it like this. We do it like this. Can't you just limit the max value you can distort? Now we want to, I guess we could, but that would be the easy solution. But this, look at this now. We're going to do this. Refraction strength. Oh, one sec. Be right back. Okay, back. Yeah, I'm pretty sure this is the way we want to go. And the second distortion here is going to be the chromatic aberration strength. So let's see here. Refraction strength, refraction direction Vs. Let's see here, refraction strength. Position world space, position SS. Ooh, how do I want to do this? So it's pretty much this offset. Ooh, yes, it's this offset here. Refraction direction. Let's remove everything with chromatic aberration right now. UV refracted. Okay, and then we do Refraction, direction, world, space. It's this one we want to rotate around. So we create this chromatic aberration matrix, chromatic aberration strength. We're not gonna choose this one here. Let's see here, view, direction, world, space. This one we want to be refraction, direction, world, space. And we want to calculate we want to offset from this one, and we want to offset by I think we want to do this. How do we want to do this? I think we want to do a refract again, so we're going to do float 3 chromatic aberration refraction direction world space is equal to refract refraction direction world space normal world space. Is this how I want to do it? Probably. And here we do chromatic aberration strength. I do -1 and 1. So we refract it twice. And then here we always do 2/3 pi. Refraction position world space. Okay, this one we want to rotate around this one. So we put this one here, chromatic aberration matrix, and this. And then we use this one here. I'm a little bit worried about having this one here though. Let's try, see what we get from this. Zero. Okay, one. I think this is what we want, but not with the outlines. Fuck, are we just gonna get... yeah, and let's try. Actually, look, does the aberration look good? I think so. Or does it? Yeah, I think so. And then we do, for the outlines here, we just do, we do a float test, but we set this one to be equal to I think we probably want to distribute around the screen space position, honestly. That would be the better solution, but for now let's do let's do this. Fuck, it's still stuck at blue, or is it? We don't get as much refraction. Okay, this is definitely, I think we're getting closer, but not entirely there just yet. Yeah, we don't want to do double refraction like this. We want to calculate the screen space position, and then we want to alter, then we want to offset from that screen space position based on chromatic aberration, I think. But so we could do it like this, actually. we do it like this. Ooh, this would probably, yeah, we don't need to do this. Refraction, direction, world space. We remove this one. Did I leave one? Yeah, here we have it. Okay, and what we do then is we do float 2 offsets. 3 is equal to float 2 chromatic aberration strength times, and then here I want to do a, what is it? I always forget. Cos 0 sin 0. Oops. Two divided by 3 times pi. So we're basically placing 3 points on a circle, and that's the offset we're going to use for this one. So screen space position, screen space, and then we do, but then again, plus offsets I. Did I forget? Yeah. Oh, this is what do we do? Refraction, position, world space. Plus offsets I. Fuck. Or maybe. We're a bit off. But if we do This is probably the way we want to do it. 0.01. Yeah, we definitely don't want to go. We probably want to do before we divide by W here. Plus this one. Okay, I think this might be. Yeah, we definitely want to limit this one as well, but yeah, so now we basically rotate around that one. But yeah, so now we're not doing this in a very physical way, I would say. Which sucks. But now if we would do outlines, we could add back this one and we do and now the outlines are always located. Yeah. Fixes the outline problem, but now we're not doing chromatic, like now we're not offsetting each channel based on normal anymore, which gives us this more uniform chromatic aberration, which I'm not a fan of. You can see that like each channel doesn't refract by itself anymore. So this is definitely not the way to go. But I think the solution we're eventually gonna go with is something akin to this. I just need to figure out exactly how I want to do it. Yeah, the outlines looks very good right now. Yeah, what we're seeing here is that we refract all the same we refract all the colors the same way, but we just have an offset to them, which gives this more uniform result, which I'm not that pleased with. So we need to do we need to refract like this, because we want the colors to we want them to wave independent of each other. But what the hell if we just do I wonder. think we're probably... Okay, so right now we distribute the chromatic aberration around view, direction, world space. We probably want to do it about refraction, direction, or if we want the outline to work, that's what we need to do. But this also, like, we're moving away from the physical, because it's actually this one we would like to alter with proper chromatic aberration. But for the best visual result, I'm not entirely sure. Okay, so this is what we're gonna do, because I need to run soon, but I'm probably gonna give chromatic aberration outlines at most an hour tomorrow. That's for like just getting it in place. If we don't succeed, I'm just gonna revert to where we don't include the outlines pretty much, and then we're gonna move to caustics. But yeah, I gotta run now, so we'll continue this tomorrow. As always, thank you so much for watching, everybody. Every input is also very much appreciated, and have a great rest of the day. Diligence, you too. Peace.